Hello again. We have reached the final video in this series for the 2020 Community Cloud Challenge, Science is Better Together. There are only a few more days officially in the challenge, but of course the Globe program and the Globe Observer app aren't going anywhere, and the activities and resources to learn, engage, and create with clouds will continue to be available on our website, observer.globe.gov. We encourage you to keep making observations beyond the challenge timeframe as long as you can do so safely and following local guidelines. Hi, I'm Kristen Weaver, and I'm the Deputy Coordinator for the Globe Observer Project. Today, we're going to get at least one answer to the questions, what happens to my data once I send it into Globe? Who's looking at it and using it? Our guest scientist, Brant Dodson, will share a few of the different avenues of research he's pursued using Globe data, and how important your observations are to his work. Then, educator Veshell Lewis will show us the Cloud Fun activity and give some tips for cloud and nature journals. After all, scientific research builds on questions we learn to ask while observing the environment around us, and it's never too early to start kids on that process as budding young scientists.
Hi, my name is Brant Dodson. I am an atmospheric scientist at NASA Langley Research Center who uses Globe data in my research. I'd like to talk for a little bit about the data that you collect, how I use that data, and why your dedication and enthusiasm for collecting and reporting weather data is so helpful for my research. I've always been a cloud watcher as far back as I can remember. I grew up in Texas and I had lots of opportunities to watch the daily summer cycle of fair weather cumulus clouds in the morning grow into raging cumulonimbus in the afternoon, providing a bit of relief from the Texas afternoon heat before decaying away at sunset. During my undergraduate study in Oklahoma, I had the opportunity to do a bit of storm chasing. And when I was in graduate school at Colorado, I was part of the local weather observing station where I would report my observations of clouds and weather occurring over the weekends. So I have some experience with watching the skies, and I know just how challenging it can be to accurately report all the different cloud and sky conditions that can occur. I came to NASA Langley in 2014 to research the properties of clouds using NASA satellites in conjunction with other meteorological data sets. My overall goal was, and still is, to help the scientific community better understand the interactions between clouds and their meteorological environments, such as how clouds are affected by temperature, humidity, and so on. I began by looking at cumulonimbus clouds occurring over the Amazon rainforest, but more recently I have studied clouds in other regions, such as over the Beaufort Sea, north of Alaska. As you've heard earlier in this video series, clouds have a major role in not only in short-term weather, but also in regulating long-term climate change. We scientists need to understand how clouds behave all around the world, and we need to use every tool at our disposal to give us the best information about cloud properties as we can acquire. Along with my previous experiences watching the sky, this is why I've become interested in the Globe Clouds Project and the data that you collect. I first became involved with using Globe Clouds data shortly after the 2017 Great American Total Solar Eclipse. I saw totality out in Idaho, traveling out there on my own volition, and shortly after I was offered the opportunity to examine the meteorological properties of the eclipse using Globe data collected specifically for the event. I was able to show a connection between the cloud cover during the eclipse with the temperature drop induced by the passing lunar shadow. More recently, I have been looking at the data collected during the Spring Cloud Challenge of 2018 and the Fall Cloud Challenge of 2019. Because these challenges were worldwide events, I was able to show how the distribution of clouds changes from region to region of Earth. One of the greatest advantages of Globe Clouds data is the satellite matching component, where your reports are linked with meteorological satellite data from both geostationary and low Earth orbits. This provides a comprehensive view of clouds from below and above. Using the satellite matched data, I have shown that both Globe participants and satellites agree closely on the distribution of cloud cover across the planet. This was a really exciting find that I was not expecting. As I mentioned, I have first-hand experience reporting weather as a ground observer, and I know how difficult it can be. So to see this close agreement between your reports and the satellites is a testament to the great work that you guys are doing. My most recent project with the Cloud Challenge data is examining the cloud cover and opacity by altitude using globe clouds data and comparing it with the satellite data. Weather and climate are sensitive to the vertical distribution of clouds, and scientists are really interested in measuring it. But these measurements can be tricky. You might think that these are NASA satellites and satellites from other scientific organizations. They can somehow magically see everything. So what help can ground observers provide? It turns out a lot, actually, because the satellites miss a fair bit of what's happening. For example, the satellites have difficulty seeing thin cirrus and cirrostratus clouds, whereas globe participants can more readily spot them. The satellites also cannot see clouds that occur low to the ground and are overlapped with clouds occurring higher up, which block the view of the satellites. You all can see these low clouds easily, and sometimes that's the only thing you can see. So it is a great help to me when you report cloud cover and cloud opacity by altitude. I know it's a bit more work, and it can be tough sometimes to estimate altitude, but it is really useful for helping scientists understand the details of clouds that can affect future climate. Related to this work, one of my most important goals is determining the certainty range of the data and the results based on the data. The reports you send in are different from measurements taken by satellites, from ground stations, and other scientific instrument sources. The main issue here is that the scientific instrument data are highly calibrated and are usually much more precise than citizen science data. And this is an important issue indeed. I've been to major science conferences and listened to well-established research scientists who ask questions about how far citizen science data can be trusted and results based on that data. So I've been looking into this, and the good news is that what citizen science data lacks in calibration, it makes up for in volume. The strength of citizen science data lies in the number of participants willing to provide lots of observations to help improve the science. I've been working on some experimental procedures to study this, and what I find over and over again is that as the number of observations provided to globe clouds increases, the messiness of the results drops dramatically. All the various uncertainties in your reports tend to average out, leaving a reliable set of results. I think this sort of research is going to be very helpful in promoting the use of citizen science within the professional scientific community going on into the future. So I can demonstrate quantitatively that the more people are willing to help out with globe clouds, and the more reports that you are willing to send in, the more reliable my scientific results become. So I'm greatly appreciative of all of your time and effort in participating in this event, and whenever else you can. And these results also show that you don't have to be too worried about sending in an observation if you aren't quite sure what kind of clouds you're seeing. Again, I know that the sky can sometimes be really complex and hard to describe, and it can be tough to figure out exactly what you're seeing. So just report the best that you can, and don't worry if you might be a little off. You're not going to hurt the science. So go have fun and tell us what you see.
Welcome to Community Cloud Challenge. I'm Dr. Veshell Lewis from Jackson, Mississippi. I am an educator at Jackson Public School District, and I have been a Globe teacher since 2013. In 2018, I had the opportunity to serve as a NASA intern at the NASA Langley Research Center in Hampton, Virginia. It was a great opportunity. I got to work with NASA scientists and NASA educators. And at the end of my internship, I was able to generate a document that aligned the globe activities with the Mississippi Science Standards. Well, today I'm going to review a globe activity with you. Globe activities are great because they're accessible to both teachers and parents anywhere. And as a teacher and parent myself, I love to use globe activities to enhance content knowledge of my students and my children. So the activity we're going to review today is Cloud Fun. Now, the purpose of Cloud Fun is to help your student or child identify cumulus clouds and the weather in which they appear. So you will need the following items. You will need this activity. You will need the elementary globe book. Do you know that clouds have names? You will need the cloud identification chart. You need construction paper, blue and white. You need glue stick, pencils and color pencils, your chart paper, and also your Cloud Fun activity sheet. Now, teachers and parents, when doing this activity, you have to first make sure that you pick a day in which cumulus clouds are present. You're going to have your student or your child go outside and make observations about those clouds. Now, encourage your student or child to use words to describe what they see. Once the observations are done, you're going to have them come indoors and you're going to review your elementary globe book. Do you know clouds have names? Now, teachers, you can read this in whole group, or you can have your students work together in small group. And lastly, you can have your students actually read this book independently. Now, parents, you can read this book with your child, or you can have your child read this book to you. The cloud identification chart is going to help you show your child or your student the different types of clouds, and you will get to review observation basics such as sky color and sky visibility. Now, once you finish reviewing your book and the chart, now you're going to actually start on your cumulus cloud look activity. For this activity, you have your students give you the descriptions that they use to describe their clouds. So cumulus clouds look like cotton candy. Cumulus clouds look like an afro. Cumulus clouds look like a pillow. Okay? So once you're done with the cumulus cloud activity, you're going to have them actually make their cloud. So the white construction paper, you will use it to cut out the cloud, and you have your student or child actually glue the cloud to the blue paper. Now, once your child or student has completed the cloud, you can display it at home or you can display it in your classroom. The next activity we'll do is weather words. Now, we've already described the clouds. Now we would like our student or our child to actually describe the weather that they experienced during this cloud observation. So students may say hot, it was breezy, it was cool, or it was sunny. And the very last activity you have your students complete is the Cloud Fun student activity sheet. Your student is going to talk about how the cumulus cloud looked to them, what was the weather that they experienced, and they also get to actually draw the cloud. Something fun that you can do with this activity sheet is actually compile them and make a cloud book. So both teachers and parents could do this. A great way also to enhance this lesson would be to use journaling. So there's two types of journaling that you can use with this activity. First is cloud journaling. What you could do is have your student or child actually go outside every day for a week, record the clouds and the weather, and then at the end of the week, you will discuss with them if the clouds present actually had a connection with the weather that they actually experienced. Okay? The next type of journaling is nature journaling. Nature journaling is great because it gives your child or student an opportunity to observe nature. Teachers, you can have your students observe the nature surrounding the school, or parents, you can have your student observe nature within your backyard. What I do encourage is for you to make sure that your student is relaxed and make sure that you encourage them to use their 5 senses when making these observations. And also motivate them to take notes, to collect samples of the things that they actually observe. Well, I've enjoyed sharing this time with you today, and I hope that you found this information to be useful. You have a good day.
Many thanks to Brant, Veshell, and all the amazing scientists and educators who have shared their expertise with us during this series. And thanks to all of you for joining us on this journey of observation and learning. We hope you will continue to engage, create, and explore about clouds and more, and remember that science is better together.